It doesn't take more than 2 gigabytes.
I'm so tired.
I don't need, because it's much easier.
Oh yeah, your hair a little bit.
Okay, we're about ready to bring things to a close for the semester. I think really what I want to try to do is bring this lecture that we were on Times Square and Rules to a close today, and really just call it quits. Sure, the study guide for those of you who are taking the exam on, well, it's going to be all of us. So, what we want to do today is finish the lecture on chi-square, basically there. Then bring things to a close. And then sure the study guide.
Will you meet y'all for someone to say that?
Yes, we're going to be on Wednesday for review. Anything you want to talk about. But don't forget our dates in terms of getting started here. Final exam for all of us is May 6th at 11 in this room. Those of you who are graduating seniors, those of you who are graduating seniors, of course, we're doing it on Wednesday at 4 o'clock. And everyone who has an excuse exam is taking the makeup business, right? No one's got an outstanding makeup. And so I think those are the deadlines that we have. All right.
Is there also, this exam will be in this one person? I said the exam, the final for the senior is also going to be in this room.
The final, we'll be here for the final. Those who are taking the senior final exam for the senior grades, come to my office at 4. Let me see the hands of those again who are taking the senior. Let me just see. I have 3 people.
It's 4 people.
Okay, let me, just give me one. Okay.
Oh, so basically, I didn't get home, so she's in there, she is so angry. I'm just so angry. I don't know what to do. That's the
Well, Ross, we ended our discussion on chi-square, and I believe I had given you a practice problem on this. The only thing I want to say is whenever you do a chi-square, a test of difference, you should probably always follow it up with a test of correlation. And on that form that I distributed to you, there are various tests, but the one I think I mentioned there was Yule's Q. Yule's Q is a simple formula that is AD. So if you label these cells A, B, C, D, or if this was, we're labeling these cells, just label across the row, which is going to be A, B, C, D, E, F. But Yule's Q is only going to work on a 2x2 table, so it wouldn't work here. So we wanted to talk about the extent to which there is a relationship between delinquency and weekend studying. We could take it by taking a ratio of A times D, cell frequencies in A times D, minus B times C, to A times B plus B times C. So, pretty simple, I mean, but it will give you a greater understanding of the data in terms of the extent of the relationship between the two variables you're interested in, rather than, as chi-square does, just simply whether or not there's a difference between two groups on the independent variable and that dependent variable. So, taking this particular data, A is 75, D is 60, that would be 75 times 60, minus BC, so that's AB times, minus BC, that would be 40 times 25, minus 40 times 25. And then do that same thing in the denominator, 75 times 60, but now it's plus 40 times 25. You do that for this data, you get 3,500 over 5,500, which is 0.64. Now, so we have a number that we can meaningfully interpret here in terms of a correlation, having a value that's going to vary between 0 and a positive 1 in this case, or 0 and a negative 1. And so when we think about how important that is that it's a significant relationship. We can go back to the criteria that we talked about when we talked about correlation in terms of substantive significance. How important is that relationship? And remember, that's what correlation is able to tell us beyond statistical significance. And we'll use the statistical significance in chi-square. There is a relationship, a statistically significant relationship between delinquency, whether or not you're delinquent or not, and whether or not you study on the weekend or not. So we've established that already. Substantive significance says that that relationship is a high one, if you remember our criteria, because the coefficient, Yule's Q, is a 0.64. A 0.64 on our diagram is falling between a 0.61 and a 0.80, which we've said, when we talk about Pearson's R, is a high relationship. So there is a high tendency in this data that when I look at the numbers for delinquents, if I want to concentrate on delinquents, for delinquents to study on the weekend. Now that's contrary to intuition, obviously, but the way you make an interpretation is direction has to do going up on one variable, or you're going up on the other variable. So going down on one variable, or you're going down on the other variable. So going from 2 to 1, that's going down, because I want to emphasize delinquency. So going from 2 to 1, going down, this is a positive relationship. What does it mean when I say going down on this variable, 2 to 1? It's studying on the weekend. So there is a high tendency for delinquents to be studying on the weekend. Okay? That includes direction now. So remember, correlation tells you statistical significance, substantive significance, direction, and as a PRE. Now the PRE is not meaningful here for Yule's Q. It does not make sense to square Q and have meaning with it. It does for R, but not for Q. So we can get 3 of those 4 ways that we can interpret a correlation out of this Yule's Q. Statistical significance, we used the chi-square. It said it was statistically significant because the observed chi-square was, from yesterday, 25.46, was in the rejection region, which started with values of 3.84 or higher. Substantive significance is a high relationship and direction. Delinquents tend to be studying on the weekend. So, and that's about all I want to say here with regard to this particular problem in terms of a test of difference when measurement on that dependent variable is discrete. Now, this only works, Q only works for a 2x3 table. If you had a table like what you have, like the practice problem that I asked you to do, prove to yourself on this, I think the hypothesis that you were dealing with was that there's no difference between skin color and perceived skin color discrimination. That is, that there's no difference between light, medium, and dark skin, and whether or not you perceive skin color discrimination or not, yes or no. That's Yule's Q is not going to work there, because that's a 2x3. So we need something like Kramer's V. Kramer's V. To make use of Kramer's V, because we've already calculated chi-square, so it's not a big jump to be able to have a coefficient that would fit the data that you have in this 2x3. You just take chi-square, in this case it's the 0.97, divided by n. And your n is 12, 20, 17, is 42. So, and of course, that's going to be very unimportant. 43?
69 is 15 plus 18 is 23.
So that again is going to be very near zero. The correlation between those two variables is going to reflect the fact that you should have concluded that there was no difference. So this chi-square is not statistically significant. That coefficient that you get, 0.00, when you make that division, 25.06 divided by 43 is equal to, you got a calculator? It should be a 0.00. Got 0.58. 0.5.
25, you want to take 5 out 43?
Yeah.
What you got?
I didn't use it.
No. 25.
43 is the end. Yeah, and this data here. All right. I think it's going to be near 0, but 0.58. But don't worry about it. We're not going to do a Kramer's V. My point is that there are other statistics out there that if you cannot do Yule's Q, that are available to you. Okay.
So we don't have to worry about this.
All right. That's all I'm going to try to do, class. Rather than trying to move into the Spearman's role and Christmas Wall. That was two tests on your tape. That was a logical speaking. So we're going to follow the one that was practical speaking, where you have tests that will allow you chi-square. If you have ordinal data that is discrete, you use chi-square. If you have ordinal data that is continuous, then just use Pearson's R, or the teacher. All right. Any questions on chi-square?
No.
All right. Let me distribute this study guide. So on Wednesday, we will meet, talk about anything we want to talk about. When you go,
So you're gonna be done at 5?
oh,
I was saying the second part.
Yeah.